Hello learners, today in this video I am going to solve a question based on JEE advanced level. Welcome back to Organic Chemwars YouTube channel. So let's get started. We are supposed to find out what is the reactant M, which upon treating with KOH forms N, right? And then we have to identify the correct statement from the given options. Let's analyze the product here. The product molecule is a cyclic molecule and also it is alpha beta unsaturated carboxylic acid. And we have a chiral carbon over here. This is the information we have from the product. In such questions, I always recommend you to go through the options because by reading out the options, it will help you to predict what is the structure of M and N. M has a chiral center with absolute configuration of S. N can show a geometrical isomerism. The precipitate which filtered off in above scheme has S4 element of symmetry. M has 8 carbons in its principal chain with the locant at the 4th position. This is the information we have from the options and we are supposed to choose either one or more right option. First thing we do is calculate the degree of unsaturation for the reactant M. What is the molecular formula given here? C9H16O2. What is the degree of unsaturation? It is calculated by the formula 2C plus 2 minus H divided by 2. When there is oxygen, we tend to ignore it. Okay. Let's calculate degree of unsaturation. So 9 multiplied by 2, that would be 18. 18 plus 2, that would be 20 minus 16 divided by 2. That means the degree of unsaturation for the given molecule is 2. That means what? It has 2 double bonds because in the question it's already given it's a cyclic compound. So there has to be 2 double bonds and also you see there are 2 oxygens. So both of them can be aldehyde or ketone or aldehyde and a ketone, that is also there. Now you know that it might have a carbonyl compound and when it is treated with aqueous KOH, that means what? It is undergoing aldol condensation to form the product because look at the product, the final product is a cyclic structure. Therefore, it's probably an aldol condensation reaction. Let's do a retro method. What do you mean by retro method? You know the product, try to identify the reactant from the product structure. So we call it as retro reverse method. Now, how we can get a aldol product? Look at this. This is alpha beta unsaturated. That means we can break the bond here, right? And then we can write a carbonyl structure here and a methyl. Now, on this carbon, there is a methyl group which is above the plane, indicating it is chiral carbon. Okay. Now, look at this. Here also there is a double bond. That means what? In aldol condensation, the alpha hydrogens are the one which will be removed to form a double bond, right? Therefore, I am going to write directly CH2 over there and then CO, right? But here we have carboxylic acid. We know carboxylic acids will not undergo aldol condensation. But also count the number of carbons here. 1, 2, 3, 4, 5, 6, 7, 8. But in the reactant there are 9. That means what? There might be a methyl group here. So this is how you can predict your reactant M. Okay. Let me repeat this once again. You have a product, right, with 8 carbon. Okay. And we are guessing it might be due to aldol condensation the product is formed. So that means what? Here there might be a ketone, right? So how to make this ketone? You introduce one more methyl here, right? So you get the reactant as M. This is one method. The other method to decide there is a methyl here is this one. Whenever you have sodium hydroxide and iodine, students, remember it's a iodoform reaction. That means what? If there is a methyl here, when you treat with NaOH, the bond is going to get cleaved here. And what about the CH3? It will form CHI3, iodoform. If you don't know what is iodoform reaction from the ketone, please go through it, then you will understand this particular part. Because they're saying filtration, filtrate, and we know that iodoform is a yellow precipitate. So that is the other hint we can get from the reaction conditions. Now let's get back to the reactant. Assuming this is our reactant, because look at this, the molecular formula is same, the degree of unsaturation is same. I told you there might be 2 ketone and the molecule has 2 ketone. So let's rewrite the structure. The same molecule I am going to write it in a better way. Okay, so we have CH3CO, right, because this is where I'm breaking the bond. Then I have a CH2, and then this is the carbon with the methyl group over here, and then we have CH2. This is the one I'm talking, right, CH2, and then here the CH2 is the one which is reacting with this, right? So then what happens here? We got CO and CH3. Now let's count the number of carbon. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right, all put together we have 9 carbons, yes, and there are 2 carbonyl, yes, and M has a chiral center, yes, it has a chiral center. And let's check the configuration also, just to check whether the statement A is right or wrong. Now we have CH2 and CH2 here. Okay, so the next priority goes to this one because there is a carbonyl. So this is first. The second priority is the CH2. The third priority is methyl. Where is the fourth priority hydrogen? Below the plane. So move from 1 to 2, 2 to 3. And what is this? It's going anti-clockwise. The fourth priority is below the plane. Therefore, this is S configuration. Therefore, the statement A is correct. Okay, now move on, because there can be more than one right option also. So we need to know what is structure N, right? So this is undergoing aldol condensation. So how do you write the aldol condensation product? Same as written here. You don't have to do the reaction and write the products, etc., because that will take lots of time. You can directly write like this. Right, let's count now. 1, 2, 3, 4, 5, 6, 7, 8, and you can see that at 4th position still we have a methyl group. So this is the molecule which is N, major product. Now, does it show geometrical isomerism? No, it doesn't show any geometrical isomerism because there is a double bond here and the molecule becomes planar, right? So all the groups will be in the same plane. Right. So for cyclic molecule, usually we have to have 2 substrates like this, AA, BB. Then you can say that if both groups are on the same side, cis, otherwise trans. That is geometrical isomerism. Therefore, the molecule N does not show any geometrical isomerism. Now, upon treating with NaOH and iodoform, students remember the methyl ketones are the compounds which will undergo this reaction. All right, so now you see it will form carboxylic acid. Why we are writing, usually we get sodium, the salt of the acid, okay, but here HCl is given, so that's why I am writing it as an acid, right? So this is the final product we got. Okay, so now what is the precipitate? As I was telling, it's a yellow color precipitate called as iodoform. The precipitate which is filtered off in the above reaction has a S4 element of symmetry. So that means what? You should know what is the structure of iodoform. So that means CHI3 like this. And we know that the carbon here is sp3 hybridized. And whenever it is sp3 hybridized, right, it's the symmetry of the molecule is S3 but not S4. Therefore, this is also a wrong statement. Let's check the last statement. M has a 8 carbon in its principal chain with the locant at the 4th position. So 1, 2, 3, 4, 5, 6, 7, 8. That is correct. And 4th position there is a locant 1, 2, 3, 4. That is methyl. Yes, that is also correct. Therefore, the right option is option D. So among the 4 statements, the right statements are option A and D. So this is how you have to approach the question. First, analyze the reaction, right? Analyze the conditions and then read the statements, because most of the time from the statements itself you can predict what are the structures of the reactants given. Okay, I hope I made this clear, and if you still have any questions about this, please comment in the comment section so that I can help you with that. Thank you for watching this video.